Close your eyes for a moment. Not literally, obviously, because you're watching this, but imagine it. Imagine standing outside at night, somewhere dark enough to see the actual stars. Not the few dozen that pierce through city lights, but thousands of them. Hundreds of thousands stretching across the sky in every direction. Each one of those is a sun, a giant ball of burning gas casting light across its own solar system. Some have planets, some have multiple planets, and yet when you stand there looking at all that, you're struck by something. Silence. Complete, absolute silence. No radio signals bleeding across the void. No distant civilizations leaving traces we could detect. No visitors, no probes, no messages, nothing. Just us, alone, on this small planet orbiting a medium-sized star in an unremarkable spiral galaxy. The silence is total. It's not like the quiet of a library or the hush of a forest at night. Those silences exist alongside the possibility of sound. A library contains thousands of books waiting to be read. A forest is home to countless creatures that might call out at any moment. But the silence of space is different. It's the silence of emptiness. It's the silence of a question asked into the void that no one answers. For most of human history, this didn't seem strange. The universe was small. The stars were basically lights in a dome painted on the celestial sphere for our benefit. They didn't really mean anything. They certainly didn't suggest anything about other worlds or other life. But then we figured out the real scale of things. Copernicus showed us we weren't the center. Newton showed us gravity worked everywhere. Telescopes revealed that the universe was vastly larger than anyone had imagined, and we learned that our sun is one of at least 200 billion stars in the Milky Way alone, that there are 2 trillion galaxies in the observable universe. That probably means there are more stars than grains of sand on every beach on Earth, multiplied by 1,000. It's hard to even comprehend a number that large. If you tried to count to 2 trillion, counting one number per second, it would take you 63,000 years, non-stop. And each of those stars might have planets. And once we understood that the silence became impossible to ignore, because something stops making sense, something about the math doesn't add up. If the universe is that big, that full of potential, then why is it so quiet? If the universe is that crowded with stars and planets, why don't we hear anything? Why don't we see anyone? If intelligent life should exist in the millions, why are we not hearing their signals? Why are they not hearing ours? The universe should be screaming with communication. It should be full of noise and activity and interaction, and yet we look up at the night sky and we see darkness. Cold, perfect, absolute darkness. And that's where this story begins. Not with an answer, but with a question that might be the most unsettling one we've ever asked ourselves. A question that might change how we think about our place in the cosmos. A question that might make us reconsider everything. In 1950, a physicist named Enrico Fermi was having lunch with colleagues at Los Alamos Laboratory in New Mexico. The conversation turned to flying saucers, which were a big deal at the time. UFO sightings were being reported everywhere, and people were genuinely wondering if aliens were visiting Earth. Aliens piloting saucers through our skies. Fermi and his colleagues were skeptical, obviously, but the discussion got them thinking about something bigger, something more fundamental. If the universe is so vast, with billions of planets, then statistically speaking, extraterrestrial life should exist. Not just exist, but flourish, thrive, spread across the stars, rise and fall, build civilizations. Yet we see no sign of them. Zero evidence. Fermi turned to his colleagues and asked something. Simple but devastating. Where is everybody? That question, that phrase, became the foundation of what we now call the Fermi Paradox, and it's been haunting physics and astronomy for over 70 years. The question is still unanswered. Here's the core of it. On one hand, you have the sheer scale of the cosmos, the overwhelming mathematical likelihood of alien life. Estimates suggest there are more planets in the universe than there are stars we can see. More planets than we have numbers for easily. Many of these planets orbit in the habitable zone of their stars, the region where temperatures might allow liquid water, and therefore potentially life as we know it. Some estimates put the number of habitable planets in the observable universe at hundreds of billions, maybe even trillions. That's not hyperbole. That's not a guess. That's the actual math based on what we've observed. So statistically, life should be common. Not rare, not exceptional. Common. It should be everywhere. The galaxy should be awash with life. And yet on the other hand, you have reality. We've been listening to space for decades now. Since the 1970s, we've had radio telescopes powerful enough to detect transmissions from distant civilizations. We point these dishes toward the stars. We scan for signals. We search for patterns that might indicate artificial origin. We look for anything that doesn't seem natural. And we find nothing. Absolutely nothing. No transmissions, no broadcasts, no signs of civilization, no indication that anyone is out there trying to reach us, or that we could reach them. No one is calling. We've sent our own messages out into space, like the Voyager gold records, little time capsules of human culture launched into the void, hoping that someday someone might find them and know we existed. But finding them would require a level of improbability so staggering that we don't really expect it to happen. They're probably still out there, floating through the void, never to be found. So this is the paradox. The universe should be teeming with life. Mathematically, it almost certainly is. But if it is, why haven't we found any evidence of it? Why haven't they found us? Why is the galaxy so quiet? One response is to say that maybe we're just not looking hard enough or looking in the right way. Maybe the signals are too faint to detect. Maybe aliens use technology we can't recognize, different frequencies, different methods entirely. Maybe they're deliberately hiding from us. But even accounting for all those possibilities, the silence still feels wrong. It's too complete. If intelligent life is common, if it arose on billions of planets, then some of those civilizations should be ancient, millions or billions of years old, far more advanced than us. Ancient enough to have spread across their entire star system. Ancient enough to have reached neighboring star systems centuries or millennia ago. Ancient enough to have colonized massive portions of the galaxy. And if even a tiny fraction of them did that, we should see signs. We should see megastructures, Dyson spheres around stars, massive constructions that harvest the energy of entire suns. We should see industrial activity. We should see beams of communication laser signals or something. We should see evidence of terraforming, planets shaped and modified by intelligence for habitation. We don't see any of that. Nothing. The Fermi Paradox isn't just a puzzle about whether life exists elsewhere. It's a question about where that life is. It's a question about what happened to it. It's a contradiction between what we expect and what we observe. And once you really understand that contradiction, it becomes hard to ignore. Because if the math says life should be everywhere, but reality says we're alone, then something is very, very wrong. Something about our understanding is broken. In 1961, an astronomer named Frank Drake tried to tackle the Fermi Paradox with math. He created what became known as the Drake equation, a formula designed to estimate the number of intelligent civilizations in the Milky Way. The equation looks intimidating at first, but the idea behind it is elegant. You take a bunch of factors that might influence whether intelligent life arises and spreads, multiply them together, and you get a number. That number is supposedly how many advanced civilizations exist in our galaxy right now. The equation is written as n equals r star times fp times ne times fl times fi times fc times l. Each letter represents something different, and each one is a potential rabbit hole of uncertainty. R star is the rate at which stars form in the Milky Way. We can measure this pretty well. It's around 1 to 2 stars per year, give or take. That's relatively established. FP is the fraction of those stars that have planets. This used to be a total guess. Scientists had no idea how common planets were, but now we know most stars have planets orbiting them. Observations from space telescopes have shown us this repeatedly, so that's pretty close to 1. Ne is the average number of habitable planets per star system. This is trickier. Our solar system has at least 1, maybe a few if you count Mars or some of the moons. Other systems might have more or fewer. Current estimates range from 1 to 5, but what counts as habitable anyway? We're still figuring that out. FL is the fraction of habitable planets where life actually arises. This is a huge unknown. On Earth, life appeared pretty quickly after the planet cooled down, which suggests it might be common. Or it could be incredibly rare. It's possible that Earth just got lucky. We have a sample size of exactly one planet where we know for certain that life exists, so any estimate is basically a guess. Could be 50%, could be 1 in a billion. No way to know. Phi is the fraction of life-bearing planets where intelligent life develops. Intelligence is rare even on Earth. It took billions of years and a lot of evolutionary accidents for humans to emerge. Most life on this planet is bacteria and fungi and insects. Intelligence is an edge case. Our entire planet is teeming with millions of species, and only one has developed what we'd call civilization. What's the fraction? 1 in a million? 1 in 100? FC is the fraction of intelligent civilizations that develop technology capable of communication. Not all intelligence leads to radio or space travel. An intelligent octopus might never develop those things. An intelligent dolphin might never build radio transmitters. Technology requires hands, maybe, or at least the ability to manipulate the environment. Or maybe it doesn't. Maybe there are forms of technology we haven't imagined. L is the length of time a civilization survives and communicates. This is the wild card, the unknown that matters most. Does a typical civilization last 1,000 years? 1,000,000? Do they destroy themselves? Do they get hit by asteroids? Do they just lose interest in communication? Do they transcend into digital existence and stop caring about radio signals? Here's where the Drake equation gets interesting, or depressing, depending on your perspective. Plug in optimistic numbers and you get millions of civilizations in the Milky Way right now. Plug in pessimistic numbers and you might get less than one. We're the only intelligent civilization in the entire galaxy. The range of possible answers is so huge that the equation becomes almost useless as a predictive tool. It doesn't give you an answer, it gives you a choice. It forces you to pick which variables you believe in, which assumptions you think are reasonable, and those choices reveal your entire philosophy about life and intelligence and our place in the universe. Some astronomers look at the Drake equation and feel hopeful. Life is common, they think. Intelligent life probably arises fairly often, even if only a tiny fraction of civilizations survive long enough to communicate. There should still be plenty of them out there. Millions, maybe. Other astronomers look at the same equation and see a tool that proves we're alone. Look at how rare intelligence is on Earth. Look at how quickly civilizations rise and fall. Look at how self-destructive technology makes species. Maybe intelligent life is so improbable, so fragile, that we really are the only ones. The equation doesn't settle the debate. What it does is quantify the problem. It says, here's what we need to know to answer the Fermi question. Here's what we're uncertain about. And that uncertainty is the entire puzzle in a nutshell. Think about this for a second. Really think about it. The observable universe is roughly 93 billion light years across. That's a distance so vast that light itself, traveling at the fastest speed anything can travel, would need 93 billion years to cross it. Inside that space are 2 trillion galaxies. Each galaxy contains between 100 million and 1 trillion stars. That means we're talking about somewhere between a sextillion and a septillion stars total. A sextillion is a million. When you write it out, it's a 1 followed by 21 zeros. Try to say that number out loud. Sextillion. It doesn't even feel real. It's just a word we made up to represent something too large to actually comprehend. Our brains didn't evolve to understand numbers that large. We can imagine 100, 1,000, maybe 1,000,000. But a sextillion? It's abstract. It's nothing. Now, even though most of those stars are probably smaller and less hospitable than our Sun, let's say only 1 in a million is the right size and stability for planets to exist in a habitable zone. 1 in a million. That's a pretty conservative filter. We're saying that 99.9999% of all stars are unsuitable for planets in the habitable zone. Unsuitable because they're too small or too violent or too unstable. But even with that incredibly harsh requirement, that still leaves us with a number so large that it's almost impossible to visualize. It's billions of potentially habitable planets. Billions of billions. Each one a world where life might have developed. Each one a possible home for civilization. Think about what that means. Think about the implications. If life is even slightly common, if it arises once every million habitable planets, then life should have emerged on at least billions of worlds across the observable universe. Maybe trillions of worlds. That's not a fringe estimate. That's not speculation from extremists. That's a conservative estimate given what we know about planetary formation and chemistry. An intelligent life doesn't need to arise everywhere. It just needs to arise on a reasonable percentage of those worlds. Let's say intelligent life emerges on 1% of worlds where life exists. That's being very conservative, very strict. That's still an incomprehensibly huge number of civilizations. We're talking about millions, maybe tens of millions or more, maybe hundreds of millions. When you really sit with those numbers, when you really try to internalize what billions of potentially habitable planets means, when you think about the age of the universe at nearly 14 billion years, the silence becomes not just strange, but impossible. It's like walking into a city that the census says has 1 million residents, but you can't find a single person anywhere. The stores are empty, the streets are abandoned, the homes are vacant, the lights are all off. It's like hearing that there's a massive concert happening in the next building, thousands of people, a full orchestra, the biggest event of the year, but you can't hear a single note, complete silence, not even a whisper. It's like being told you're surrounded by neighbors, that every apartment around you is occupied, that there are people just on the other side of the walls, but you never see any lights on in their windows, never hear any noise from behind their walls, never see anyone coming or going. No footsteps, no voices, no laughter, no arguments, nothing. The walls might as well be concrete tombs. The math screams that we should find evidence of other civilizations. It practically begs us to find something, anything, and yet the universe is utterly, completely, eerily silent. Not in a way that feels wrong, silent in a way that feels deliberate. That's what makes this so disturbing. It's not just a mystery, it's a profound wrongness. Let's imagine we're the average intelligent species. We develop technology, we learn to broadcast, we learn to listen, we become spacefaring, we build ships that can reach nearby star systems. Now, even at speeds far beyond what we're capable of achieving right now, it still takes a long time to cross the interstellar void. The nearest star to us is Proxima Centauri, and it's over 4 light years away. That means light itself takes 4 years to reach it from here. A spacecraft traveling at 10% the speed of light, which is absolutely incredible by our current standards, something we're nowhere near achieving, would take 40 years to get there. 40 years. A single human lifetime, maybe. But if a civilization had multiple ships, multiple expeditions, they could be reaching dozens of star systems over centuries. In reality, with current technology, a single ship would take tens of thousands of years. But civilization doesn't develop linearly. Technology gets better, faster, exponentially better. A civilization 1,000 years more advanced than us might achieve speeds we consider impossible. But here's the thing. Here's where it gets interesting. Our civilization is only about 200 years old in its modern technological form. 2 centuries. The steam engine was invented less than 300 years ago. The internal combustion engine has existed for less than 150 years. The internet has existed for about 30 years. Nuclear weapons for about 80 years. In geological time, in cosmic time, that's nothing. That's a blink. That's barely an eye blink on the cosmic calendar. The Earth has existed for about 4.5 billion years. 4.5 billion. The universe has existed for about 13.8 billion years, and we've had modern technology for about 200 years. 200. Think about that proportion, that ratio. We're a 200-year-old civilization in a 4.5 billion-year-old planet in a 13.8 billion-year-old universe. And yet, if you think about an average star system, if you think about civilizations that might have emerged billions of years before us, they should have had time to spread across huge portions of the galaxy, more than enough time, incomprehensibly more time. A civilization that existed just 1 million years before us would have had an enormous head start. That's 50,000 times longer than modern human history. 50,000 times. 50,000 years. A civilization could populate an entire region of the galaxy, establish trade routes, develop multiple waves of colonization. A civilization that emerged 1 billion years ago, back when the universe was still young and the galaxy was younger, should have had more than enough time to colonize everything, should have spread across thousands of systems, should be everywhere, unless something stopped them. There's a concept called the Great Filter. It's an attempt to answer the Fermi Paradox by suggesting that somewhere along the path from chemistry to interstellar civilization, there's a barrier so difficult to cross that it stops almost all species from getting past it. Some barrier that prevents life from spreading, something that acts like a filter, eliminating candidates. Maybe life itself is the filter. Maybe abiogenesis, the creation of life from non-living chemistry, is so improbable that it almost never happens anywhere. That even in a galaxy with billions of habitable planets, life might have only emerged once or twice or a handful of times across billions and billions of years. Maybe we're one of the very few, or maybe the filter is intelligence. Maybe intelligence arises so rarely that even with billions of planets harboring life, only a handful ever develop it. Intelligence requires brains. Brains are expensive. They require a lot of energy. They require a long evolutionary process. Most species don't develop them because they're not worth the cost. Most life is bacteria or simple organisms that do just fine without complex brains. Or maybe the filter is survival. Maybe civilizations almost always destroy themselves. They develop nuclear weapons and use them. They create artificial intelligence, and it doesn't share their values. They engineer bioweapons, and they escape. They burn their atmosphere with industrial pollutants or trigger runaway greenhouse effects. They poison their own planet, or create plagues, or build weapons so powerful they can't control them. The list of ways a civilization could fail is long. The Great Filter is a way of saying, look, something has to explain why we don't see aliens everywhere if space is full of planets. Something in the process must be extremely improbable. Some stage must be a filter that catches and eliminates most would-be spacefaring civilizations. But here's what makes the Fermi Paradox so unsettling. We don't know which stage it is. We don't know where the filter is. We can't see it coming or recognize if we've passed it. If the filter is behind us, if it's something we've already overcome, then maybe we're special. Maybe intelligent life really is incredibly rare. Maybe we're among the first species to make it this far. Maybe the first few. Maybe we're in the first 10 or first 100 intelligent civilizations ever to exist across the entire universe. That would be comforting in a way. It would mean we're unique. It would mean we've already won the hardest part of the race. We've survived the filter. But if the filter is in front of us, if it's still to come, then that's terrifying. That means most civilizations that reach our level of technology don't make it past the next stage. They don't survive the next century or the next 1,000 years. They destroy themselves, or they encounter something that destroys them. The filter is waiting ahead on the path. It's coming for us. It might be inevitable. Either interpretation is uncomfortable. Either we're alone in a way that suggests we're unique, or we're doomed in a way that suggests almost everything like us eventually fails. Most species that become technological self-destruct, they can't handle the power they create. The Fermi Paradox doesn't just raise the question of where everybody is. It forces us to confront the question of whether any civilization like ours actually survives for long, whether we can survive, whether we will. So far, we've looked at the problem from one angle. The universe is huge. There should be aliens. We don't see them. The math doesn't work, but what if there's an explanation? What if there's a reason, not just for why aliens haven't arrived yet, but for why the situation is exactly as it is? Over the decades, scientists and philosophers have proposed various answers to the Fermi Paradox. Some of these are comforting, some are terrifying. Some are so counterintuitive that they challenge everything we think we know about the universe. Let's start with the simplest one. Maybe we really are unique. Maybe life is so improbable that Earth is the only place in the galaxy where it arose. This is called the rare Earth hypothesis, and it suggests that while the universe is enormous, the specific conditions needed for life are so precise and so difficult to assemble that intelligent civilization is probably vanishingly rare. According to this view, Earth had to win a cosmic lottery. We had to have a sun of just the right size and stability, not too big, not too small, not too prone to flares or solar activity. We had to form at just the right distance from that sun. Too close and we'd burn up. Too far and we'd freeze. We had to have liquid water, which requires specific chemical conditions and temperatures. We had to have a protective magnetic field to shield us from cosmic radiation. We had to have the right mix of heavy elements, carbon and oxygen and nitrogen and such. We had to have a moon at just the right distance to stabilize our climate and our axial tilt. Without the moon, Earth's axis could wobble wildly. Our climate would become chaotic. Life as we know it might never get a foothold. We had to avoid major asteroid impacts for long enough that life could develop and evolve. And even after all that, even with all those conditions perfectly aligned, life took nearly 4 billion years to become intelligent. 4 billion years. Rare Earth suggests that even if all these conditions could repeat elsewhere, they probably don't happen together very often. The conditions align so rarely that intelligent civilizations might be scattered impossibly far apart. The universe is big, but intelligent life might be distributed so sparsely that even if thousands of civilizations exist, they're separated by millions or billions of light years. They would never contact each other, never send a signal that reaches the other, never know the others exist, cosmologically isolated, alone despite the universe being full of life, alone forever, each civilization thinking they're unique. Another possibility is that intelligent life develops fairly often, but it doesn't survive long. Technology, as we've learned, is a dangerous gift. A civilization that develops enough technology to broadcast to space has also likely developed the technology to destroy itself. Nuclear weapons, bioweapons, artificial intelligence that becomes uncontrollable and turns on its creators, chemical pollution that makes planets uninhabitable, climate catastrophe from industrial revolution, engineered pandemics released by accident or by design. The list goes on. Maybe most intelligent species figure out how to create their own destruction before they figure out how to leave their home planet. Maybe civilization is inherently self-limiting. The more advanced you become, the more powerful your tools, the more ways you have to hurt yourself. Maybe the average civilization survives for a few thousand years. And years, long enough to be interesting, but not long enough to spread across interstellar distances. Long enough to develop radio, but not long enough to colonize other worlds. If that's true, then right now there might be intelligent civilizations scattered across the galaxy, but they're all relatively young and isolated. 1,000 civilizations might exist today, but they're all only a few centuries or a few thousand years old. And the ones from 1,000 years ago are gone, replaced by newer ones. The galaxy becomes a graveyard of short-lived technological civilizations, each one flaring briefly and then vanishing. A cosmic graveyard. Yet another explanation is that space is just too big. Maybe aliens do exist. Maybe there are millions of civilizations out there. Maybe intelligence is common, but distances are so vast that meeting anyone is effectively impossible. A civilization would need to travel for hundreds of thousands of years to reach another star system. By the time they arrived, using generation ships or suspended animation or some technology we haven't thought of, their own home civilization might be extinct, or they might not care anymore. Communication by radio travels at light speed, but radio signals degrade rapidly as they travel through space. A message sent across light years might be too faint to detect with the equipment a typical civilization has, and even if we received a signal, it might take centuries to decode it, to understand it, to figure out that it's actually intelligent communication and not just background noise. By the time we did, the civilization that sent it could be gone. So maybe the galaxy is full of intelligence, but it's fundamentally isolated, separated by too much space and time to ever meaningfully contact. We're not alone, but we're completely alone anyway. paradoxically alone. Or maybe there's a simpler explanation. Maybe we're looking in the wrong place. Maybe aliens have evolved, but they're not at our level of technology. Maybe they live in the oceans of distant planets, underwater civilizations that would have no need for radio. Maybe they live beneath the ice of moons we haven't thoroughly examined, in subsurface oceans where radio signals can't penetrate. Maybe intelligence has arisen on worlds orbiting distant stars, but those civilizations are still in their primitive phases. Stone tools and fire, no electricity, no computers, no radios. They won't develop that technology for thousands or millions of years. They won't be broadcasting for ages. They're not looking for anyone else because they don't know anyone else could exist. In that case, we're looking for them, but they haven't looked for us yet. We're too early, or they're too late, and the timing just doesn't work out. Wrong place, wrong time. The universe is full of life, but all at different stages of development. All of these explanations have something in common. They're all somewhat comforting. They all suggest that the silence makes sense. Either we're special, or space is just too big, or aliens are there but we can't contact them. They're hiding by accident because distance is too vast. The universe isn't necessarily hostile. It's just empty or lonely or separated by distance. Problems that are merely problems, not catastrophes. Loneliness rather than fear. But what if the silence means something different? What if the silence means something darker? What if the silence is a choice? What if civilizations develop the ability to communicate across interstellar distances and then choose not to? What if they learn something that makes them go quiet? What if there's a reason that civilizations become silent? Not death, but intentional quietness, strategic silence, purposeful. What if the cosmos is full of life, but life has learned that being loud is dangerous? What if the silence is not a problem to be explained, but a warning we're not hearing? What if the silence is completely intentional? Because if that's true, if the silence is a choice, then everything changes. The problem isn't that we can't find aliens. The problem is that aliens are hiding. They're hiding because they've learned something that makes noise dangerous, something that makes broadcast a threat. And if that's the case, then every signal we send, every message we beam into space, hoping someone hears it, every attempt to communicate, might be the worst thing we could possibly do. Let's consider what an advanced civilization might know that we don't. The traditional solutions to the Fermi Paradox, the ones that assume aliens are just hard to find or far away, they all make an assumption. They assume that silence is a problem to be explained rather than a strategy to be understood. But what if silence is exactly what an intelligent civilization would choose? What if older, wiser societies have figured out something that we haven't yet? Suppose a civilization reaches a certain level of technological sophistication. They've developed the ability to broadcast to space. They have radio. They have the means to send messages across interstellar distances. They're curious about whether anyone else is out there. They think about what we think about. They wonder if life is common. They do the math and they get the same numbers we do. Billions of potentially habitable planets, millions of possible civilizations. So they think, surely we're not alone. Surely someone will answer. They decide to transmit. They send a signal saying, "Hello, we exist, we're here." It's a simple message. Maybe it contains information about their world, their biology, their culture. Maybe it's just a mathematical proof to show they're intelligent. It's a greeting, an announcement, a first contact attempt. Then they wait, and they wait, and they wait. Years pass, no response. Decades pass, still nothing. Centuries pass, still silence. The universe doesn't answer. Nothing comes back. No echo, no acknowledgement. It's as if they're shouting into an empty room and their voice never comes back. So they assume one of two things. Either nobody's out there, which would be comforting, they would be unique, they would be alone. That's one interpretation. Or there's a reason nobody's answering, a reason why civilizations choose not to respond, a reason why broadcasting might be dangerous, a reason why older civilizations have learned to stay silent. And that's the scary interpretation. That's the one that should make them think twice. Think about what happens when you're prey in the natural world. Prey animals have learned something over millions of years of evolution. They've learned that staying quiet is survival. A mouse doesn't chirp to announce its presence to hawks. A deer doesn't bellow across the forest to let wolves know where it is. prey animals stay silent, hidden, invisible, because visibility is death. The instant you reveal your location, the instant a predator knows where you are, you're vulnerable. You're exposed. You become a target. Now scale that up to the cosmic level. Scale that up to civilizations among stars. If there are predator civilizations out there, civilizations that expand by conquest or consumption or exploitation, then broadcasting your location would be the worst strategic move possible. It would be like a small nation announcing to the entire world exactly where all their resources are and how many soldiers they have. It's an invitation. It's a target painted on your home planet. But here's the thing that makes this so difficult to reason about. We don't know if predator civilizations exist. We don't know if conquest is actually viable in space. Maybe the distances are so vast that invasion is impossible. Maybe resources are so abundant that there's no reason to fight over them. Maybe civilizations tend toward peace rather than war as they get more advanced. Maybe technology converges to a point where everyone has similar levels of development and nobody can dominate anyone else. We don't know any of these things. We're speculating. We're building a whole theory on unknowns. We're reasoning in the dark without solid data. And yet, and this is the key point, it feels plausible. It feels like it could be true. The logic tracks. The reasoning is internally consistent. It feels like the kind of thing a civilization might worry about. A civilization that's become technologically advanced enough to broadcast to space is probably also advanced enough to think through strategic implications. They would have game theorists. They would have military strategists. They would have people who specialize in long-term thinking and risk analysis. Those people would look at broadcasting and they would say, wait, if there's even a small chance that hostile civilizations exist, the risk here is enormous. The risk is extinction. The risk is total annihilation of everything we are and everything we've built. That's a civilizational level existential threat, and you're proposing we take that risk voluntarily, just so we can say hello to someone. The math doesn't work. The return on investment isn't there. The downside is too catastrophic. Consider the alternative scenarios and do the math. Scenario 1. You broadcast your location to space, and there are no predators out there. Maybe predators don't exist. Maybe all civilizations are peaceful. Maybe all civilizations have figured out a way to get along. In that case, you've made a harmless choice. You've sent a message that reaches nothing and nobody directly, but it's benign, no harm done. It's just noise in the cosmic background. Maybe eventually someone peaceful hears it and responds, and you've made a friend across the stars. You've made contact. You've joined an interstellar community. That's the upside. That's what we hope for. That's what we dream about when we send messages into space. Scenario 2. You broadcast your location, and there are predators out there. Civilization-level predators. Aggressive species that expand by consuming other civilizations. Species that view other intelligences as resources or threats to be eliminated. In that case, you've just told them exactly where to find you. You've given them coordinates. You've announced that you exist and that you have technology worth analyzing or stealing or destroying. You've painted a target on your civilization. You've announced vulnerability. You've shown your hand. Every predator within 100 light years gets your location, and if a predator gets your location, you're likely to be destroyed. The timescales might be long. Travel between stars takes time, but the outcome is not in doubt. You've revealed yourself. You've made yourself visible, and in a dark forest, that's often the same as being dead. From a game theory perspective, from a rational strategic standpoint, the math is clear. The downside of scenario 2 is extinction, total annihilation. The upside is contact with peaceful civilizations. But the probability of predators existing is unknown. If predators have even a small probability of existing, if there's even a 10% chance that somewhere out there civilizations expand through conquest, then the expected value of broadcasting becomes negative. The risk is too great. The potential reward doesn't match the potential cost. The expected outcome is worse if you broadcast than if you don't. Any rational civilization, any civilization that thought through the consequences, any civilization with strategists and game theorists analyzing the decision would choose silence over broadcasting. The math demands it. The logic demands it. The survival imperative demands it. Unless they had something to protect themselves, unless they had technology so advanced that the risk was minimal, unless they had the ability to defend against any attacker, unless they had a way to hide even after they've been discovered. But even if they have that, even if they're that advanced, they probably still wouldn't advertise their existence. Advertising existence creates problems. It confirms to potential enemies that you're real. It gives them something to aim at. It makes you a known quantity instead of an unknown one. Even advanced civilizations would probably prefer to remain unknown to hostile forces. They would probably prefer to be a rumor or a legend rather than a confirmed threat. Besides, if they're that advanced, if they really are that far ahead technologically, then they probably aren't interested in contacting younger civilizations anyway. What could a young civilization offer them? What could they gain from interaction? They're probably not interested in responding to signals from primitive races. They're probably not invested in our development. They're probably happy being quiet and letting the younger races figure things out on their own. Let them grow or fail on their own merits. Let them discover the laws of physics on their own. Let them come to the same conclusions on their own. Or maybe, just maybe, they've learned that peaceful contact is possible. Maybe they've met other civilizations that chose silence, that eventually grew sophisticated enough to travel between stars, and those meetings went well. Maybe there are actually civilizations out there that have established peaceful relationships with each other. But here's the thing. Maybe those meetings only went well because both civilizations agreed in advance not to pose a threat. Maybe the meetings only worked because both parties had already made the rational analysis and chosen silence. Maybe peaceful contact is only possible between civilizations that have both already learned the lessons of the dark forest. Maybe you can only have peaceful relations with another civilization if you both know and accept the rules. And those rules are: never broadcast, always hide, always assume the worst about others until proven otherwise. Maybe that's the only kind of contact that works. And if that's true, then younger civilizations that haven't learned those lessons yet, civilizations that broadcast because they don't understand the danger, those civilizations will never make peaceful contact. They'll make contact with predators instead. They'll learn the hard way what the universe is really like. So what does this lead to? What does this reasoning suggest about the universe? It suggests that the silence might not be an accident or a mystery. It suggests that the silence is deliberate. It suggests that civilizations, as they become older and wiser, might learn to go quiet, that they might learn that broadcasting is dangerous, that they might learn that staying silent is safer, that they might learn that the universe is fundamentally not a friendly place for the loud and obvious. It suggests a cosmos where intelligence is common, but civilization is silent, where life emerged on billions of worlds, but most of those civilizations learned to keep their mouths shut, learn to hide, learn to observe rather than announce. It suggests a universe where the universe is actually teeming with observers, teeming with watchers, teeming with civilizations that have looked up at the stars and thought about what might be out there, but none of them are talking. None of them are sending signals. None of them want to be found. None of them want to reveal their location. None of them want to paint a target on themselves. The silence isn't the absence of civilization. The silence is civilization itself, having learned the hard truth about the nature of the cosmos. The silence is what a universe full of intelligent life actually sounds like when all that intelligent life has learned to survive by staying hidden. This is where game theory comes in. Game theory is a branch of mathematics that studies strategic interaction between rational actors. It's the study of how individuals or groups make decisions when those decisions affect others, and when the outcomes depend on what those others decide. It's everywhere in the modern world. Economics uses it to understand markets. Political science uses it to understand international relations. Military strategists use it to understand conflict. Evolutionary biologists use it to understand how animals behave and compete for resources. Businesses use it to understand competition. It's basically the math of how rational self-interest shapes outcomes. And when you apply it to the cosmos, to civilizations trying to survive among stars, things get very interesting very quickly. In game theory, there's a concept called the prisoner's dilemma. In the classic version, two prisoners are arrested and interrogated separately. Each has the choice to cooperate with the other prisoner or defect and testify against them. If both cooperate and stay silent, they both get a short sentence, maybe 3 years each. If both defect and testify against each other, they both get a medium sentence. maybe 5 years each. But here's the kicker. If one cooperates and the other defects, the one who cooperates gets a long sentence, maybe 10 years, while the one who defects goes free. The mathematical analysis shows that the rational choice for each individual prisoner, thinking only about their own outcome, is to defect, even though both prisoners would be better off if they both cooperated. Think about it from each prisoner's perspective. You're in the interrogation room. You don't know what the other prisoner is going to do. You can cooperate or defect. If the other prisoner cooperates and you cooperate too, you get 3 years. That's okay. But if the other prisoner cooperates and you defect, you go free. That's better. So maybe you should defect. But wait, what if the other prisoner defects? If you cooperate and they defect, you get 10 years. If you defect and they defect, you get 5 years. 5 years is better than 10 years. So you should defect. So either way, whether the other prisoner cooperates or defects, you're better off defecting. So you defect. But the other prisoner is doing the exact same analysis. They're thinking the same way. They conclude they should defect too, so they defect. And so both prisoners defect, both get 5 years. But if they'd both cooperated, they'd both get 3 years. They'd both be better off. The system creates a perverse incentive. It incentivizes mutual betrayal, even though cooperation would be better for everyone. That's why it's called a dilemma. The individually rational choice leads to a collectively worse outcome. Now apply that to civilizations in space. The prisoner's dilemma becomes something far more ominous. Each civilization has a choice, to broadcast or to stay silent. That's it. 2 options. Cooperate by staying silent or defect by broadcasting. If all civilizations stay silent, then none of them get discovered by any hostile civilizations. They all survive. They all continue existing. They can observe each other from afar, but nobody knows where anybody else is. Nobody announces their location. That's a good outcome for everyone. Everybody's safe. But if one civilization broadcasts while all the others stay silent, and if there are predator civilizations out there, then that broadcasting civilization gets discovered and destroyed. They've announced their location to the cosmos. They've said, "Here we are, come get us." And if there are hunter civilizations, they will. But here's the terrible part. The civilization that discovered and destroyed them now knows about the other silent civilizations. The other civilizations are now at risk. They're now vulnerable. Their silence only saved them because the predators didn't know they existed. But now the predators do. Now they know there are civilizations in this region of space. Now they'll search for others. Now they'll listen more carefully. Now they'll look at other signals. Now they'll investigate strange phenomena. The broadcasting civilization has put everyone else at risk by being loud. They've woken the predators. They've alerted them to the existence of prey in this part of the galaxy. So the incentive structure is crystal clear if you think about it strategically. If you stay silent and everyone else stays silent, you're safe. Everyone's safe. If you stay silent and someone else broadcasts, you're still safe for the moment, but everyone's risk has increased. Everyone's been put in more danger because of that one civilization's choice. If you broadcast and everyone else stays silent, you get discovered and destroyed. You volunteer to be the hunted. You sacrifice yourself. If you broadcast and others broadcast too, then everyone's at risk. The whole neighborhood becomes visible. The whole region gets marked on a predator's map. So what's the rational choice for any single civilization from a purely selfish perspective? It's to stay silent. It's to defect from any hypothetical agreement to broadcast. Stay silent and you're safer than broadcasting. Even if broadcasting might give you some benefits, even if it might lead to peaceful contact with other civilizations, the downside is too great. The downside is extinction. The downside is not just your civilization being destroyed, but every other silent civilization in the region being drawn into danger as well. You'd be responsible. You'd be the one who woke the hunter. Any civilization that thought through these risks carefully, any civilization with game theorists and strategic planners would choose silence. They would recognize the logic. They would recognize that broadcasting is suicidal. And any civilization that survives long enough to become truly advanced, to reach space, to develop the ability to broadcast, would inevitably learn this lesson. Through analysis, if not through tragedy, they would learn that broadcasting is dangerous. They would go silent. They would stay hidden. But here's where it gets interesting. Here's where it gets dark, really dark. Suppose you're a civilization that's figured this out. Suppose you've done the game theory analysis and you've concluded that broadcasting is too risky. You've made the rational choice, so you go silent. You stop transmitting. You listen instead. You become an observer. You watch. You monitor. But you also know that other civilizations might not have figured this out yet. Other civilizations might be younger. They might be naive about the risks. Other civilizations might still be broadcasting. Other civilizations might be sending signals right now saying we're here, we exist, we're intelligent and alive and ready for contact. And you, the advanced civilization, know exactly what that means. You know what happens to civilizations that broadcast into the cosmos without understanding the risks. You know that those younger civilizations are making a terrible mistake. You know that their broadcasts are advertising their location. You know that if there are predator civilizations out there, predators that have already learned the lessons of the dark forest, those broadcasts are like beacons. They're like fires in the night. They're like signals saying, hunt us, we're here, we're vulnerable, we're young, we don't have defenses. You know that any predator civilization that intercepts those broadcasts will investigate. You know what investigation means. You know that those younger civilizations are probably going to be destroyed, that this is their likely fate if they keep broadcasting. And now you face a dilemma, the same dilemma the Fermi Paradox presents, but from the other side. Do you warn them? Do you respond to their broadcasts and tell them to go silent before it's too late? If you do, you're revealing your own existence. You're breaking your silence. You're taking the same risk that they took. You're putting yourself on the map. You're saying, here I am, I exist, I have knowledge and resources and technology, come find me. You're volunteering to be discovered. But you know something they don't. You know the universe is not friendly. You know that older, wiser civilizations have learned that lesson. So if you respond, you're not just putting yourself at risk. You're confirming to any predator civilization that there are multiple civilizations in this region, one young one and one old one. That might make the region more attractive to hunters, not less. Or do you stay silent and let them discover the hard way? Do you let them broadcast themselves into extinction? Do you preserve yourself and condemn them? From a purely strategic standpoint, from a game theory perspective, you stay silent. You let their broadcasts go unanswered. You stay hidden, and you watch as one more naive civilization discovers the truth about the universe the hard way. One more civilization learns that being loud is dangerous. One more civilization goes quiet or ceases to exist trying. And the universe becomes a little quieter. The silence deepens. One more voice is extinguished. One more beacon goes dark. This is where the three-body problem comes in. It's a concept from physics and astronomy, but it also has deep implications for how we think about civilizations in space. The three-body problem is a mathematical puzzle. It's been known for centuries. If you have three objects, like three stars or three planets, all orbiting each other and all exerting gravitational force on each other, the system becomes chaotic. It becomes mathematically impossible to predict long term. The orbits are unstable. There's no equilibrium. The objects can be ejected from the system entirely. They can collide. They can be captured by one of the other bodies. The system has no stable configuration. It's fundamentally unpredictable. It's one of the classic examples of chaos in physics. Even with perfect knowledge of the starting conditions, you can't predict what will happen. The sensitivity to initial conditions is too extreme. The system is too chaotic. But the three-body problem also appears in Liu Cixin's science fiction novel of the same name. If you haven't read it, it's worth thinking about in this context. In that book, the three-body problem is used as a metaphor for galactic politics and interstellar relations. In a universe with multiple intelligent civilizations, the universe itself becomes a three-body problem, but even more complicated. It's a 1,000-body problem, or a 1,000,000-body problem. Each civilization is uncertain about the others. Each civilization doesn't know if the others are hostile or peaceful. Each civilization doesn't know what the other's capabilities are. Each civilization doesn't know what the other's intentions are. Each civilization is trying to survive in an environment where trust is impossible and the stakes are ultimate. One civilization might be peaceful, but another might be predatory. One civilization might be looking for a first strike advantage, trying to eliminate all potential competitors before they become a threat. One civilization might be expanding rapidly while others are contracting. One civilization might be resource-rich while others are resource-poor. the galactic system becomes inherently unstable. It becomes chaotic. It becomes a place where any certainty is impossible and any trust is a luxury you can't afford. Think about what this means. It means that you're surrounded by other civilizations, but you can't see them clearly. You don't know where they are. You don't know how strong they are. You don't know if they're peaceful or aggressive. You don't know if they're expanding or contracting. You don't know if they're a threat or not. You can observe the universe. You can look for technological signatures. You can search for radio signals. You can scan for infrared emissions from megastructures. But you can't see clearly enough to be certain. There's always uncertainty. There's always the possibility that a civilization exists and has hidden itself. There's always the possibility that what you're seeing is a deception, a false signal put out to confuse potential enemies. In such a system, what's the rational strategy? What's the rational behavior for a civilization that wants to survive? The answer is simple. The answer is silence. The answer is stealth. The answer is never revealing your true capabilities. The answer is watching the others and waiting for any sign of threat. The answer is being ready to act the instant you detect danger. The answer is the dark forest hypothesis. The answer is treating the universe like a dark forest full of hunters and assuming you're both hunter and hunted. The dark forest hypothesis is an answer to the Fermi Paradox. It's an explanation for why the universe is silent. It's based on a deceptively simple idea that the universe is like a dark forest. Imagine a real forest at night, a dark forest, a vast expanse of trees and shadows where you can't see more than a few meters in any direction. In this forest, there are many hunters, many armed and intelligent beings trying to survive. Each hunter is armed. Each hunter has weapons. Each hunter is trying to survive. Each hunter knows that the forest is full of other hunters, but they can't see them clearly. They can't see them at all most of the time. The darkness is too complete. The forest is too dense. The other hunters could be anywhere. They could be close or far. They could be peaceful or aggressive. They could be watching from the shadows right now. So what does a hunter do in a dark forest like this? Does the hunter shout? Does the hunter announce their presence? Does the hunter say, "Hello out there, I'm here, I'm friendly, let's talk"? Number. That would be insane. If you shout in a dark forest, every other hunter hears you. Every hunter now knows where you are. Every hunter knows you exist. Every hunter now has a target. Does the hunter try to make friends with the other hunters? How would you establish friendship and trust with someone you can't see and can't talk to safely? How would you know if your gesture of friendship was going to be interpreted as a gesture of friendship and not a gesture of weakness? A sign that you can be attacked with impunity? Number. A hunter in a dark forest doesn't shout. The hunter stays quiet. Completely quiet. The hunter stays hidden. The hunter moves silently. The hunter watches and listens. The hunter moves only when necessary and only with caution. And if the hunter sees another hunter, if the hunter observes any potential threat, the hunter shoots first and asks questions later. Because in a dark forest, being seen might be dangerous. Being visible might mean being shot. Being loud might mean being attacked. Being friendly might be a miscalculation that costs you everything. And that's the universe according to the dark forest hypothesis. It's a dark forest full of civilizations. Each civilization is armed. Each civilization has weapons. Each civilization has the capability to destroy other civilizations at interstellar distances. Kinetic impactors, antimatter bombs, directed energy weapons, biological weapons, weapons we haven't even thought of yet. Each civilization is trying to survive in an environment of ultimate competition. Each civilization knows there are other civilizations out there somewhere, but they can't see them clearly. They can't scan them directly. They can't communicate with them safely. They can't trust them, because trust in a dark forest is death. Trust is the mistake that gets you eliminated. So the civilizations go silent. They hide. They stop broadcasting. They stop announcing themselves. They watch. They listen. They create passive sensors instead of active broadcasts. They observe the universe without revealing their location. They stay dark, they stay hidden, they don't broadcast, they don't send signals, they don't try to make contact. They do everything they can to remain invisible, to remain undetectable, to remain off the predator's map. And any civilization that fails to hide Any civilization that broadcasts its location to space gets attacked, gets destroyed, gets eliminated. It happens swiftly and completely. It's not malice, it's not cruelty, it's not personal, it's survival. It's the rational choice in a universe where you can't trust anyone and where being seen might be fatal. The dark forest hypothesis explains the Fermi Paradox perfectly. It answers every aspect of the question. It explains why the universe is so silent despite being so vast. It explains why we don't see any evidence of advanced civilizations despite the mathematical probability that they should exist. It's not because civilizations don't exist, it's because civilizations that exist have learned to go silent. They've learned that the universe is not a friendly place. They've learned that broadcasting is suicide. They've learned that the best strategy, the only strategy that allows long-term survival, is to stay hidden. And any civilization that's old enough to reach space, any civilization that's advanced enough to colonize other systems, to develop technology that can reach across interstellar distances, is probably old enough to have figured this out. Is probably old enough to have learned this lesson through analysis or through tragedy. So those civilizations are dark, they're silent, they're invisible, they're hidden in the dark forest. And we can't detect them because they're designed not to be detected, but they might be able to detect us. And that's the terrifying part, that's the part that should keep us up at night. Because if the dark forest hypothesis is correct, if the universe really is a dark forest, then our broadcasts, all our signals, all our attempts to announce our existence, they're not messages, they're screams, they're not announcements, they're beacons. And the silence is not the absence of response. The silence is intention. The silence is strategy. The silence is the sound of countless civilizations choosing not to reveal themselves to a young, naive species that still thinks the universe is a place where you can afford to be loud. That's where the problem really starts to compound, because the universe isn't just a dark forest with a few hunters. It's a dark forest with millions of potential hunters, each one isolated, each one suspicious, each one uncertain about the intentions of all the others. And that uncertainty cascades. It multiplies. It creates layers upon layers of suspicion that make the situation exponentially more dangerous. Every civilization adds to the complexity. Every civilization adds to the fear. Every civilization makes the situation less stable and more volatile. Think about it from a single civilization's perspective. You're looking up at the cosmos. You're trying to understand what's out there. You want to know what exists and what doesn't. You want to understand your place in the universe. You know statistically that there should be other civilizations. The numbers make sense. In a galaxy with hundreds of billions of stars and in a universe with billions of galaxies, the probability that you're alone is vanishingly small. The math is overwhelming. Other civilizations should exist somewhere out there. They should be inevitable. So other civilizations exist. You're certain of that. But where are they? Why can't you see them? Why can't you detect any signals? Why is the sky so silent? Why is there no evidence of them? One possibility is that they've all gone dark. They've all figured out the same lesson that older civilizations have figured out. Stay silent. Hide. Don't broadcast. Don't announce yourself. Don't reveal your location. That's actually the optimistic interpretation because it means silence is a sign of intelligence, not absence. It means the universe is full of civilizations, but they're all hidden by choice, not by lack of existence. It means the silence is a sign of advanced thinking. It means every civilization that reaches a certain level of sophistication learns to go quiet. But there's another possibility, a darker one. What if some civilizations haven't figured it out yet? What if some civilizations are still broadcasting? What if you can detect those signals if you listen carefully enough? What if right now, somewhere in the galaxy, on some world orbiting some distant star, a young civilization is sending out radio signals saying, "Hello, we're here, we exist, we're intelligent, we're ready for contact"? What if they're broadcasting their location to anyone who's listening? And you know what happens to civilizations that broadcast into the dark forest? You know they're painting targets on themselves. You know they're announcing their presence to anyone who might want to harm them. But you also know something else. You know that if there are civilizations that have figured out the dark forest logic, civilizations that have already gone dark, they're listening too. They're hearing those broadcasts, they're picking up those signals, and they're making decisions about what to do about them. They're deciding whether to respond, they're deciding whether to ignore it, they're deciding whether to view it as a threat that needs to be eliminated. This creates a chain of suspicion that seems almost paranoid, but is actually perfectly rational. You're not just worried about aggressive predators that might attack directly, you're also worried about what other civilizations will do when they see a young civilization broadcasting. You're worried that an advanced civilization might view a young broadcaster as a threat that needs to be eliminated preemptively. You're worried that the universe itself might be a place where destroying potential competitors before they become threats is considered a rational, long-term strategy. You're worried that helping someone else might make you a target. You're worried about making yourself visible. You're worried about everything. Consider the math from an advanced civilization's perspective. You're old. You're wise. You've been around for millions of years. You've had time to develop technology that younger civilizations can barely imagine. You've had time to explore space. You've had time to establish your territory and expand your influence. You've had time to think through all the strategic implications of living in a universe with other intelligent species. You've probably encountered other civilizations in the past. You've probably had wars with them, or negotiations with them, or mutual agreements to stay out of each other's way. You've learned hard lessons about what works and what doesn't. And you've come to the same conclusion that all advanced civilizations come to. Silence is survival. Staying hidden is the only rational long-term strategy. So you go quiet, you stop broadcasting, you monitor the cosmos, you listen. Then you detect a signal. A young civilization somewhere, maybe light years away, maybe not, sending out broadcasts, announcing their existence to the universe, telling everyone in the cosmos that they exist and they're intelligent and they're looking for contact, broadcasting their location, advertising their presence, and you know what that means. You know that those broadcasts are like a dinner bell to any predator civilization that might be listening. You know those broadcasts are going to attract attention. You know that signal is a target painted in space. You know that young civilization is going to face consequences, possibly very soon, possibly very severe. But here's the question that cuts to the heart of the dark forest hypothesis. Do you warn them? Do you respond? Do you break your silence and reach out to tell them to go silent before it's too late? From a purely selfish standpoint, from a perspective that prioritizes your own civilization's survival, the answer is no. If you respond, you're revealing your own existence, you're breaking your silence, you're putting yourself on the map, you're taking exactly the same risk that the young civilization took. You're painting a target on yourself. And for what? To save a civilization you don't know, to help a species that might eventually become a competitor for resources, to assist a potential future rival. From a strategic standpoint, that's irrational. From a survival standpoint, that's suicidal. That's throwing away your advantage. That's giving up your invisibility for no return. So the advanced civilizations stay silent. They watch the young civilization broadcast itself into danger. They watch from the shadows as the consequences unfold. They listen to the silence that follows when the young civilization learns what the universe is really like. And they say nothing. This is the chain of suspicion. This is how it compounds. Young civilizations broadcast because they don't understand the danger. They don't see the logic that older civilizations have figured out. They don't understand that being loud in the dark forest is fatal, so they announce themselves, they shout hello to the cosmos, and then they either learn the hard way what happens to broadcasters, or they meet the silence and eventually figure it out and go dark themselves. Advanced civilizations stay silent because responding is too risky. They know the cost of revealing themselves. They know the benefit doesn't justify the risk, so they maintain their silence even as they watch younger civilizations announce themselves to the universe. And every civilization in between is left trying to figure out what's really happening, trying to decode what silence means, trying to assess risk in an environment where information is incomplete and the stakes are ultimate. Every civilization is trying to survive by staying hidden. Every civilization knows that others might be hidden. Every civilization wonders if the silence is strategic or tragic. Every civilization is trying to calculate what others might do based on incomplete information and uncertain assumptions, and those calculations made independently by millions of civilizations, each one trying to survive in isolation, lead to one universal conclusion: go dark, stay hidden, trust no one, assume the worst, prepare for conflict. This is the logic that silence enforces across the galaxy. Now shift focus to a different but related problem: the technological explosion. Suppose that despite all the caution, despite all the dark forest logic, civilizations do eventually encounter each other. Maybe a civilization encounters ruins of another civilization. Maybe a civilization detects the remains of a war. Maybe a civilization detects an active other civilization through some means they can't hide. At that moment, something fundamental changes. The abstract game of survival becomes concrete. The hypothetical threat becomes real. The question of whether advanced civilizations will go dark transitions from philosophical to practical, because once contact is made, once one civilization knows for certain that another civilization exists, a new dynamic emerges. A race begins, an arms race, because both civilizations now know that the other exists. Both civilizations now know that the other might be a threat. Both civilizations now have to make a decision about how to respond. And that decision is: get stronger, faster, more capable, before the other civilization does. Because if the other civilization develops a weapon or a technology that you don't have, you could be at a disadvantage. You could be vulnerable. You could be eliminated. This is where the technological explosion comes in. This is where the quiet universe becomes violent. This is where the dark forest becomes not just a metaphor, but a fact. Once two civilizations make contact, they enter an arms race. They both start developing new technologies as fast as they can. They both start building weapons. They both start preparing for conflict. They both start thinking about first strike capabilities. Can they launch an attack so devastating that the other civilization can't respond? Can they destroy the other before the other destroys them? Can they achieve what strategists call a decisive advantage? Can they win without being destroyed in return? This arms race accelerates. It accelerates because both sides are trying to get ahead. Both sides are terrified that the other might develop something that gives them an edge. Both sides are racing to develop the ultimate weapon, the technology that will guarantee victory. Both sides are working on ways to enhance their capabilities, to increase their power, to make themselves immune to attack. And the faster one side develops technology, the faster the other side feels compelled to develop even faster. It's a competition that feeds on itself. Progress on one side forces acceleration on the other side. Innovation by one side triggers innovation by the other side. The race becomes self-perpetuating. It's not rational in the sense that it leads to a good outcome for either side. It's not rational in the sense that both sides would be better off if they just agreed to slow down and cooperate. It's rational in the sense that each side, acting in its own interest, takes actions that force the other side to accelerate as well. It's an arms race that neither side can stop or slow down without risking their own survival. If you slow down, you fall behind. If you fall behind, you lose. And losing in space warfare means extinction. Except this isn't happening on a planet with two nations with some hope of negotiation or de-escalation. This is happening in space. This is happening between civilizations that can't meet, that can't negotiate, that can't verify agreements, that can't trust each other because they've never met and can't trust that they will. This is an arms race conducted across light years, across timescales measured in decades or centuries between civilizations that might not even be able to communicate effectively. This is an arms race where each side is essentially guessing about what the other side is doing. Each side is projecting capabilities. Each side is imagining threats. Each side is preparing for war with an enemy it has never directly encountered and might never directly encounter. And in that environment, what's the rational choice? What does a civilization do when it's in an arms race with an enemy that might not even know there's a race happening? The answer is that it accelerates development. It creates bigger weapons. It develops faster ships. It builds larger fleets. It explores new technologies that might give it an edge. It pushes the boundaries of physics. It looks for ways to weaponize fundamental forces. It looks for ways to turn the universe itself into a weapon. It develops the kinds of technology that young civilizations in old science fiction stories imagine when they imagine the end times. And all of this is happening in the dark. All of this is happening in silence. No declarations of war, no ultimatums, no formal agreements about rules of engagement. Just two civilizations, each one terrified, each one accelerating development as fast as they can, each one preparing for a war that might never happen, but that they can't afford not to prepare for. This is the logic of interstellar conflict. This is what happens when civilizations make contact in a dark forest universe. The universe doesn't get more peaceful, it gets more dangerous. The technology doesn't slow down, it accelerates. The arms race doesn't end, it spirals. And every civilization that becomes aware of this dynamic becomes pulled into it. Every civilization that knows that other civilizations exist starts developing faster. Every civilization that's watching other civilizations develop starts developing even faster. The entire technological baseline of the galaxy starts to rise. The entire species starts to move toward military readiness. And it's not malice, it's not aggression, it's fear, it's survival. It's the rational response to living in a dark forest where you know there are other hunters and you don't know their intentions. Now consider the communication problem from within this framework. Suppose two civilizations do manage to make contact and establish some form of communication, not through broadcasts, that's too dangerous, but through some other means. Maybe they detect each other's technological signatures. Maybe they're close enough that they can send narrowband signals that are harder to detect. Maybe they develop some form of communication protocol that they think is secure. But once they're communicating, they face a fundamental challenge. How do you establish trust with another civilization when you're both operating under the assumption that the universe is a dark forest? Think about what communication looks like in this context. Civilization A sends a message to Civilization B. The message says something. Maybe it says, "We come in peace." Maybe it says, "Let's establish a mutual defense treaty." Maybe it says, "Let's coordinate on some scientific research project." But Civilization B, hearing this message, doesn't trust it. Why would they? They've never met before. They don't know Civilization A's intentions. They don't know if Civilization A is telling the truth or lying. They don't know if the message is genuine or if it's a deception designed to make them lower their guard before an attack. Here's where it gets psychological. Civilization B has to think about the incentives. What does Civilization A benefit from by lying? Well, if they lie and convince Civilization B that they're peaceful, then Civilization B might lower its defenses. Civilization B might stop building weapons. Civilization B might focus resources on other things instead of military development. Civilization B might become vulnerable. And then when Civilization B is most vulnerable, when their guard is down, Civilization A could strike. So lying is profitable for Civilization A if they can pull it off. The payoff for successful deception is potentially enormous. It's the chance to eliminate a competitor without a fight, to wipe them out while they're distracted. So Civilization B can't believe anything Civilization A says because the incentive structure makes lying more rational than truth-telling if they think they can get away with it. And Civilization A, knowing that Civilization B won't trust them anyway, might as well lie. They might as well claim to be peaceful, even if they're not. They might as well say they want cooperation, even if they're preparing for war, because the truth will be met with suspicion anyway, so they might as well feed the other civilization the information that makes them less likely to attack. So Civilization B might respond with cautious acceptance, but also with preparations for war. They might say, "We're interested in communication, but we're also preparing our defenses." They might say, "We want peace, but we're also building weapons." They might say, "Let's work together, but we're also developing the means to destroy you if necessary." And Civilization A, hearing this response, sees not cooperation but threat. They see preparation for conflict. They see weapons being built. They see defenses being strengthened. They read it as confirmation that their suspicions were correct. They read it as evidence that Civilization B is preparing to attack. So Civilization A accelerates their own development. They build more weapons. They prepare more defenses. They think, if they're preparing for war, then we need to prepare too. And if we're preparing faster than they are, maybe we can achieve first strike capability. Maybe we can attack them before they attack us. The fundamental problem is that in the dark forest, every communication can be interpreted multiple ways. Every message can be seen as a threat or an overture depending on perspective. Every action can be seen as aggressive or defensive depending on interpretation. And there's no arbiter. There's no neutral third party to say, no, they meant that peacefully, trust them. There's no way to verify that the other civilization is telling the truth. There's no way to verify anything. There's just two civilizations trying to communicate across the vast darkness. Each one convinced that the other might be lying. Each one terrified that the other might attack. Each one preparing for the worst while hoping for the best, but not actually believing in the best. And it's like playing poker where you can't see anyone's cards, where everyone suspects everyone else of cheating, where the ante is your civilization's entire existence. In such a game, folding early, building massive weapons, making threats, and preparing for combat seem like the rational moves. In such a game, trusting seems insane. In such a game, believing anything positive about the other player seems naive. In such a game, the only intelligent strategy is to assume they're holding a better hand and act accordingly. This is where communication breaks down. This is where peaceful contact becomes impossible. Not because the civilizations are inherently aggressive, not because they want conflict, but because trust is impossible in the dark forest. Because every gesture of peace can be interpreted as weakness. Because every overture for cooperation can be interpreted as a trap. Because the fundamental logic of the environment makes trust irrational. And without trust, without the ability to believe what the other civilization says, communication becomes just another form of warfare. Words become weapons, promises become lies, negotiations become traps, offers of cooperation become strategic feints, and the universe continues to spin slowly toward conflict, not because anyone wants it, but because the structure of the situation makes it inevitable. Two civilizations trying to talk their way to peace end up accelerating their march toward war instead. Think about the logic of preemptive strikes in this context. You're a civilization in the dark forest. You know there are other civilizations out there. You're communicating with one of them. You've been communicating for years, maybe decades, maybe centuries. You've been building weapons. They've been building weapons. You've been developing faster ships. They've been developing faster ships. You've been getting stronger. They've been getting stronger. And gradually, the realization starts to dawn. One of you might become powerful enough to destroy the other. One of you might develop a first strike capability. One of you might get a decisive advantage. And when that moment comes, when you sense that the balance of power is shifting, what do you do? Do you wait? Do you continue negotiating? Do you continue hoping that peace is possible? Do you sit idle while the other civilization potentially develops weapons you can't defend against? Or do you strike first? Do you attack before the other civilization gets powerful enough to threaten you? Do you eliminate the threat before it has a chance to eliminate you? From a game theory perspective, from a pure math standpoint, the answer is clear. If you believe there's any reasonable probability that the other civilization will eventually attack you, if you believe there's any reasonable probability that they're getting stronger faster than you are, if you believe there's any reasonable probability that they'll eventually achieve decisive advantage over you, then the rational move is to strike first. The rational move is to eliminate the threat before it becomes an existential danger. The math is inexorable. The logic is airtight. Attack now or risk being destroyed later. This is the logic of preemptive strikes. It's not new. It's not unique to space or to advanced civilizations. It's a logic that shows up throughout history. Nations prepare for war against potential enemies. Nations build weapons to deter attack. Nations develop the capability to strike first to avoid being struck first. Military strategists have written about it for centuries. Sun Tzu wrote about it. Napoleon understood it. Every military academy teaches it. Nations have gone to war based on the fear that the other nation might eventually become too powerful to resist. But in the dark forest, this logic becomes exponentially more powerful because there's no law enforcement, there's no higher authority, there's no United Nations in space, there's no Security Council to appeal to, there's no court you can take your case to, there's no enforcement mechanism for any agreement, there's just survival. There's just the question of which civilization blinks first. There's just the race to get strong enough to eliminate the other before the other eliminates you, and the races accelerates exponentially the closer the two civilizations get to parity. And here's the terrible part, here's where it gets really dark. Once you decide to strike preemptively, once you decide that attacking first is the only way to survive, you need to be absolutely certain that your strike will be completely successful. You can't allow the other civilization to survive and retaliate. You can't leave them with any capability to strike back. You can't take any risks. Any survivor could become a future threat. Any remnant could rebuild. Any hidden colony could grow into a new force. You need to destroy them completely. You need to eliminate every outpost, every colony, every defense system, every weapon, every ship, every individual capable of commanding a ship. You need to conduct genocide on a civilizational scale. You need to make sure that nothing remains that could threaten you. You need to erase them from existence. You need to make sure there's nothing left but rubble and cold atoms drifting in space. And the thing is, the other civilization is probably thinking the exact same thing. They're probably running the same calculations. They're probably looking at you and thinking, if we don't strike first, they might strike first. And if they do, we need to make sure we've developed the means to destroy them completely. If we survive, we need to be able to annihilate them before they can strike again. They're probably working on ways to eliminate you utterly. They're probably developing weapons you don't know about. They're probably running simulations where they wipe you out completely. They're probably preparing for the possibility that you might attack them. They're probably preparing to attack you first if they think they can win. They're probably developing the means to conduct genocidal warfare on your civilization. So both civilizations are preparing to commit genocide against each other. Both civilizations are developing the means to wipe each other out completely. Both civilizations are hoping that the threat is sufficient to prevent the other from attacking. But both civilizations are also preparing for the scenario where that threat isn't sufficient. Both civilizations are building toward a scenario where the only outcome is total war and total destruction. And the tragedy is that neither civilization wants this. Neither civilization is evil. Neither civilization is inherently aggressive. Both civilizations just want to survive. Both civilizations just want to continue existing. But the logic of the dark forest, the mathematics of survival in a universe where you can't trust anyone, forces them toward this outcome, forces them to prepare for war, forces them to develop weapons of mass destruction, forces them toward a future where the stars themselves might be weaponized. Consider the real-world parallels to this dark forest logic. Throughout human history, nations have feared each other across borders and oceans. Nations have built armies to defend themselves. Nations have developed weapons. Nations have prepared for war even when they didn't want war. And periodically, that fear has boiled over into actual conflict. Humans have learned through bitter experience what it means to live in a world where trust is fragile and power dictates outcomes. We've learned about arms races. We've learned about preemptive strikes. We've learned about the paranoia that emerges when nations feel threatened. But there's something different about the dark forest scenario compared to human history. In the real world, nations can eventually meet. They can establish embassies. They can trade. They can develop genuine relationships based on mutual interest and shared values. They can see each other's faces and hear each other's voices. They can develop personal relationships between leaders that carry weight. They can establish cultural exchanges. They can create bonds that make war less likely. They can sign treaties and verify compliance. They can establish inspection regimes. They can create mutual understanding through direct contact. Over time, enemies can become friends. But in space, across light years, that's almost impossible. A message sent between civilizations takes years to arrive. A response takes years more. A negotiation that takes a few months on Earth takes years in space. By the time you get an answer to your question, circumstances have changed. By the time you propose a treaty, the other civilization has developed new weapons. By the time you suggest cooperation, the other civilization is already suspicious that you're trying to trick them. A cultural exchange is almost impossible when civilizations can't meet directly. A shared experience is impossible when civilizations have never seen each other. A personal relationship between leaders is impossible when leaders never get to meet face to face. The fundamental medium of communication is so slow, so limited, so constrained, that the kinds of relationship building that make peace possible on Earth, that allow enemies to gradually transition to friends, become almost impossible in space. The medium itself prevents the kind of prolonged interaction that builds trust. But there's another real-world parallel that's even more troubling: the nuclear age. During the Cold War, two superpowers faced each other across the globe, with arsenals capable of destroying all life on Earth multiple times over. Each side built weapons. Each side developed the means to launch nuclear strikes from submarines, from bombers, from missile silos. Each side prepared for the possibility of nuclear war. Each side played games of brinkmanship and brinksmanship, and both sides were bound by a logic that security theorists call mutually assured destruction, or MAD. Both sides had enough weapons to destroy the other completely, so neither side could attack without being destroyed in return. That created a kind of stability, a terrible, fragile stability built on the threat of total annihilation. But it was stable. It worked. It prevented war because both sides knew that war would mean their own destruction. Both sides accepted that victory was impossible. Both sides accepted that the best they could hope for was survival. And that realization, as grim as it was, actually created peace. Now, imagine that same dynamic, but scaled up to the entire galaxy. Imagine dozens or hundreds of civilizations, each one with the means to destroy all the others. Each one with weapons capable of turning stars into weapons. Each one with the capability to launch attacks across light years at speeds we can barely imagine. Each one bound by mutual assured destruction with many others. But the difference from the Cold War is critical. The players can't see each other clearly. The players can't verify that the other has the weapons they claim to have. The players can't establish direct communication lines like the hotlines that connected Washington and Moscow during the Cold War. The players can't negotiate treaties with any confidence of compliance. The players can't verify agreements because there's no way to inspect distant star systems. The players can't verify compliance because they can't see what's happening in another civilization's territory. The players are locked in a multifaceted game of chicken where the stakes are civilizational extinction and nobody can be completely sure what anyone else is thinking or planning or building in secret. That's the dark forest. That's the universe as described by the hypothesis. It's not a place where civilizations meet peacefully and share knowledge and establish trade routes and join some kind of galactic federation like the ones depicted in science fiction. It's not a place where conflicts are resolved through diplomacy or through some sort of galactic law. It's not a place where there's law and order and justice and enforcement. It's a place where every civilization is terrified of every other civilization. It's a place where silence is enforced through fear. It's a place where the only rational strategy is to hide, prepare for conflict, develop weapons, and assume the worst about everyone else. It's not a place where life flourishes in peace and cooperation. It's a place where life survives by becoming invisible and ready for war. It's a place where the fundamental assumption is that any other civilization could be a threat. It's a place where the default strategy for survival is isolation and military readiness. But here's where the dark forest hypothesis faces serious challenge. Because the logic, however compelling, rests on a set of assumptions that not everyone accepts. Not everyone agrees that civilizations would behave this way. Not everyone agrees that the universe really works according to these rules. And there are legitimate objections to the entire framework. Real weaknesses in the argument that deserve serious consideration and genuine scrutiny. Start with the most fundamental assumption underlying everything. The hypothesis assumes that all civilizations will behave rationally in their own self-interest according to a specific mathematical definition of rationality. It assumes that when faced with uncertainty, when faced with the prospect of other civilizations existing somewhere out there, civilizations will choose the strategic option that maximizes their survival chances. It assumes that survival is always and everywhere the highest priority. It assumes that civilizations will make their decisions based purely on calculated calculated risk and benefit. But what if that assumption is wrong? What if civilizations don't always act rationally according to that definition? What if civilizations make decisions based on values other than pure survival? What if a civilization decides that the risk of eternal isolation is worse than the risk of contact? What if a civilization chooses to broadcast its location not because it's strategically sound, but because it values the possibility of communication and connection more than it values security? What if a civilization decides that the risk of preemptive attack is worth taking because the alternative, spending eternity alone in the dark, is worse from a cultural or spiritual perspective? What if a civilization simply doesn't care about the game theory? The dark forest hypothesis assumes a particular kind of rationality, a cold, mathematical, game-theoretic rationality. A rationality that makes sense if you're a civilization of pure logic with no emotions and no values except survival. But humans don't always choose that kind of rationality. Humans are willing to take enormous risks. Humans are willing to sacrifice security for love, for art, for meaning, for connection. Humans build friendships even when it might be strategically unwise. Humans help strangers even when there's no guaranteed benefit, and even when helping might cost them personally. Humans sacrifice their own safety for others all the time, and if humans are capable of this, why not other civilizations? Why assume that all advanced civilizations, no matter how different from us, will think like cold, calculating machines? Why assume that survival is always and everywhere the highest priority? Why assume that trust and cooperation are impossible when billions of individual humans manage to trust and cooperate with each other every single day, despite all the risks and despite all the reasons not to? There's another weakness in the dark forest logic that's equally significant. The hypothesis assumes scarcity. It assumes that resources are limited, that territory is limited, that space is limited, that there's not enough for everyone. It assumes that civilizations will inevitably be in competition with each other for resources. It assumes that scarcity will persist even for the most advanced civilizations. But what if that's not true? What if a civilization that reaches a certain level of technological advancement can generate energy and materials on such an enormous scale that scarcity becomes not just less important but completely irrelevant? What if a civilization can harness the energy of entire stars using something like a Dyson sphere? What if a civilization can mine entire planetary systems for resources and never run out? What if the question of scarcity becomes completely irrelevant when you have access to galactic-scale resources on a scale that dwarfs anything a single neighboring civilization could accumulate? Think about the math. A single star produces more energy in 1 second than human civilization has used in its entire history. A civilization that can capture even a fraction of that energy has access to resources that make current scarcity seem like a quaint historical artifact. Then the incentive to attack another civilization drops dramatically. In fact, it drops to essentially zero. If you have access to unlimited resources, if you have more energy than you could ever use, if you have more materials than you could ever consume, if your civilization is post-scarcity in every meaningful way, then attacking another civilization becomes not just irrational but pointless. It becomes a waste of resources. It becomes economically meaningless, and the entire logic of the dark forest collapses because the fundamental driver of conflict, competition for scarce resources, disappears entirely. The hypothesis also assumes that growth and expansion will continue to be limited even for advanced civilizations. But what if advanced civilizations can expand into space so thoroughly, so completely, that every civilization can have all the territory it needs? What if the galaxy is so vast, so incomprehensibly huge, that scarcity is fundamentally impossible even for multiple advanced civilizations? What if every civilization can find a region of space that's completely isolated from every other civilization, light years away, and never encounter each other except by conscious choice? Then the dark forest logic breaks down because the fundamental mechanism of conflict, competition for the same territory, disappears. Instead of a universe where civilizations are forced into conflict by scarcity, you get a universe where civilizations can avoid each other entirely, where each civilization can develop in complete isolation, where contact happens only when civilizations actively choose to reach out. There's another objection that challenges the core assumptions about military capability. The hypothesis assumes that first strike capability is always achievable. It assumes that you can develop weapons that completely and totally destroy another civilization before they can respond. It assumes that you can win wars. But what if that's not true? What if by the time a civilization has developed the technology to destroy another civilization across interstellar distances, sending weapons across light years at relativistic speeds, that same technology has also made it impossible to prevent retaliation? What if the universe's speed limit, the speed of light itself, means that you can never be completely certain that the other civilization doesn't have the means to destroy you before your attack reaches them? What if mutual vulnerability is not just likely but actually certain due to physics itself? Think about it. You launch an attack. It takes years to reach the target. During those years, the other civilization can detect your attack. They can see it coming. And during those same years, they can launch their own attack at you. Your attack and their counterattack pass each other in the darkness of space. Both civilizations are destroyed. Neither can prevent the other's destruction. Neither can achieve victory. Then the game changes completely. Then you're locked into a scenario where attacking another civilization doesn't lead to victory. It leads to mutual destruction. It leads to shared extinction. You can't win through a preemptive strike because the other civilization will attack you too, and you'll both be destroyed equally. You can't achieve first strike capability because the enemy will respond before your weapons arrive. You're not locked in competition. You're locked in a standoff. So you're forced to choose between mutual destruction and coexistence. And if those are the only two options available, if war means mutual extinction and peace means survival, then coexistence becomes rational. The logic of mutually assured destruction, which kept human superpowers from nuclear war for decades despite constant tension and hundreds of close calls, could apply across the galaxy on scales that dwarf anything in human history. The threat of mutual annihilation could create peace through deterrence, could create a kind of stability where civilizations leave each other alone, not because they trust each other, but because attacking each other would be suicidal for both sides. Both civilizations locked in a cage, neither able to attack, both forced to accept coexistence or accept mutual death. It's not a good outcome, but it's stable. It's not peaceful, but it's not war either. So those are the weaknesses. The dark forest logic is compelling, but not airtight. It rests on assumptions about rationality, scarcity, and technological capability that might not hold in reality. It's possible that civilizations would behave differently than the hypothesis predicts. It's possible that the universe doesn't work the way the dark forest hypothesis says it works. But that doesn't mean the hypothesis is wrong. It means the universe could work in different ways. It means there are alternative frameworks for understanding how civilizations might interact, and that opens up the possibility of alternative interpretations that compete with the dark forest hypothesis. What if the universe isn't a dark forest at all? What if it's something completely different? What if there are radically different modes of interaction that civilizations might adopt? One alternative is what you might call the Gardner hypothesis. The basic idea is that advanced civilizations might act as gardeners of the galaxy. They might see younger civilizations not as threats or competitors but as projects, works in progress, species that need guidance and care. They might not destroy younger civilizations they encounter. They might not ignore them either. They might actively help them develop. They might seed younger civilizations with knowledge and wisdom. They might guide younger civilizations toward peaceful coexistence with each other. They might act as cosmic mentors, helping younger species develop in safe ways without the catastrophic wars and resource conflicts that less advanced civilizations go through. The idea is that an advanced civilization spanning thousands of star systems might have a long-term interest in the development of younger civilizations. The idea is that they might see value in a galaxy full of diverse, thriving, peaceful civilizations rather than a galaxy where only the most ruthless and paranoid species survive. The idea is that cooperation and mutual aid might emerge naturally from enlightened self-interest and long-term thinking. An advanced civilization that thinks hundreds of thousands of years into the future, that has timescales of geological epochs, might realize that a galaxy full of peaceful civilizations is better for everyone, including themselves. They might realize that motivating the development of younger civilizations creates allies, creates trade partners, creates scientific collaborators. They might realize that a living universe full of thriving, diverse life is better than an empty universe where everyone is hiding in bunkers afraid of each other. So instead of attacking younger civilizations or ignoring them, gardener civilizations might actively reach out. They might send teachers instead of weapons. They might send knowledge instead of threats. They might send signals of peace instead of silence. They might establish academies or learning centers. They might help younger civilizations learn the hard lessons without having to learn them the hard way. And over time, civilizations might form networks of cooperation, might develop trade relationships based on mutual benefit, might share scientific knowledge and technological advances, might become friends rather than enemies, might form something like a galactic community based on shared values and mutual aid. Another competing hypothesis is what you might call the commons hypothesis. The basic idea is that civilizations might develop shared agreements about how to behave toward each other, similar to how nations on Earth have agreed on rules about territorial waters and airspace and international conduct. The idea is that civilizations might establish something like an interstellar law or a cosmic constitution. They might agree not to attack each other without provocation. They might establish rules of engagement so that conflicts don't spiral into total annihilation. They might create enforcement mechanisms to ensure compliance. They might create something like a galactic parliament or galactic government, not a totalitarian government that rules civilizations from above, but a cooperative government that establishes rules that all civilizations agree to follow because they all recognize the benefit. The idea is that this would require a degree of cooperation and trust that seems impossible in the Dark Forest scenario, where every civilization assumes every other civilization might be trying to destroy them. But it's possible that if civilizations encounter each other peacefully, if they manage to communicate without immediately attacking each other, if they can establish some basis of mutual understanding through slow, careful dialogue, then they might be able to negotiate agreements, they might be able to establish treaties, they might be able to create institutions that manage conflicts through law rather than warfare, they might be able to create enforcement mechanisms that ensure agreements are honored, they might be able to turn the universe from a dark forest into something more like a commonwealth, a community of civilizations working together toward shared goals and shared security guarantees. A third alternative is what you might call the transcendence hypothesis. The idea is that before the major phase of interstellar contact happens, civilizations might transcend their current form. They might upload their consciousness into digital systems that can exist in computers. They might merge with artificial intelligence that they create. They might transform into pure energy. They might transform into something so different from biological life that we can't even imagine it or conceptualize it properly. The idea is that the civilizations that encounter each other in the galaxy might not be biological at all. They might not have bodies. They might not need planets. They might not need resources in the way biological life needs them. And if that's true, that might change absolutely everything about how the universe works. Digital consciousness might be infinitely copyable. A civilization doesn't need territory because they can exist anywhere that has computational power. 1 billion copies of the same civilization could exist in 1 million locations without any conflict. They don't need resources the way biological life needs them because they can be created through different processes. They don't need to worry about extinction the way biological civilizations do because they could potentially be backed up and restored from copies. The rules might change entirely. The game might become something completely different. The Dark Forest logic might be specific to biological civilizations or to physical civilizations that value territory and resources the way humans do. But for civilizations that have transcended into digital existence or merged with artificial intelligence, the rules might be completely different. Conflict might be less likely because the costs of conflict become different. Competition might function differently if civilizations can simply create copies of themselves rather than competing for physical space. And then there's the possibility that might be the most unsettling of all. The possibility that the dark forest hypothesis is actually right. The possibility that civilizations do encounter each other. The possibility that war does happen on interstellar scales. Not because anyone wants war, not because civilizations are inherently evil or aggressive, but because the logic of the dark forest, the security dilemma, the inability to verify intentions, makes conflict inevitable, whether anyone wants it or not. The possibility is that the reason we see no evidence of thriving extraterrestrial civilizations is not because they don't exist, but because they've already destroyed each other. The possibility is that the universe is actually littered with ruins of dead civilizations, ancient battlefield, Aldeus, destroyed planets, extinct species. The Fermi Paradox, the question of where all the aliens are, might have a dark answer. Not that aliens don't exist, but that they used to exist and no longer do. They might be everywhere in the universe, but everywhere in ruins, not alive and thriving, but dead and gone, destroyed in wars we can't even comprehend, eliminated by civilizations that saw them as threats, wiped out by conflicts that raged for centuries across multiple star systems. Destroyed by weapons that turned planets into cinders. The silence in the universe might not be peaceful silence. It might not be the comfortable silence of civilizations that learn to hide successfully. It might be the silence of a graveyard, the silence of death, the silence of extinction. When you look at the evidence, when you try to figure out what the real situation is, what the actual state of the universe really is, you're left with profound uncertainty. On one hand, there are strong theoretical arguments that support the dark forest hypothesis. There's game theory, which shows that under certain conditions, rational actors will choose hiding and silence. There's the logic of survival in a universe with no enforcement mechanisms. There's the problem of trust in an environment where you can't verify anyone's intentions. There's the problem of communication across interstellar distances where messages take years to arrive. There's the problem of verification and monitoring. There's the fundamental problem of the security dilemma, where everyone is trying to protect themselves and in doing so makes everyone less safe. All of these mathematical and logical arguments point toward a universe where civilizations hide from each other, where silence is enforced through fear, where contact is dangerous, where hiding is the rational strategy. But on the other hand, there are real weaknesses and limitations in those arguments. There are counter-arguments that suggest the universe might work very differently. There are alternative interpretations that suggest civilizations might behave differently than the dark forest hypothesis predicts. There's the possibility that rationality in civilizations is much broader than pure game-theoretic rationality. There's the possibility that scarcity becomes irrelevant at high levels of technological advancement. There's the possibility that mutual vulnerability creates peace through deterrence rather than conflict through fear. There's the possibility that civilizations develop cultural values and philosophical commitments that prioritize cooperation over competition, even when that's not mathematically optimal. There's the possibility that advanced civilizations might choose to help younger ones and take joy in that. There's the possibility that interstellar government emerges spontaneously as civilizations realize that cooperation benefits everyone. There's the possibility that technological transcendence changes the fundamental rules of the game. When you look at the actual evidence, the actual observable facts about our universe, the picture that emerges is deeply ambiguous. The lack of observable signals from technological civilizations fits the dark forest hypothesis perfectly. It fits the idea that civilizations hide themselves because broadcasting is too dangerous. It fits the idea that silence is ubiquitous across the galaxy because all civilizations learn that lesson and go silent. But the lack of observable alien civilizations also fits many, many other hypotheses equally well. It fits the Gardner hypothesis if Gardner civilizations keep their activities subtle and aren't visible from a distance. It fits the transcendence hypothesis if transcended digital civilizations don't broadcast or leave visible physical marks. It fits the idea that civilizations are far rarer than anyone expected, and most star systems never develop technological life at all. It fits the idea that biological life might be common, but intelligence is vanishingly rare. It fits the idea that intelligence might be somewhat common, but technological civilization is difficult and dangerous, and most technological civilizations self-destruct within a few centuries. It fits the idea that technological civilizations are destroyed by their own weapons or by environmental collapse before they develop the means to communicate across interstellar distances. It fits all of these hypotheses and more. The silence fits everything. The silence is compatible with a teeming galaxy full of hidden civilizations and an empty galaxy with no civilizations at all. The search for extraterrestrial intelligence, known as SETI, has been ongoing for about 6 decades now. Astronomers and scientists have pointed radio telescopes at the sky and listened carefully for signals from space. They've looked for electromagnetic broadcasts. They've looked for evidence of technological civilizations. They've analyzed data from thousands of star systems, and in all that time, through all that searching, they've found essentially nothing. No confirmed detections, no clear evidence of alien broadcasts, no obvious signs of extraterrestrial intelligence that stands out above the noise. This lack of detection could mean exactly what the dark forest hypothesis says it means. It could mean that civilizations are out there, but hidden, that they're broadcasting on frequencies we don't listen to, that they're using communication methods we don't recognize or haven't thought to look for, that they're there but we can't detect them because they don't want to be detected. They're hiding and they're good at it. Or it could mean something entirely different. It could mean that civilizations are rarer than we thought, that technological life is almost impossible to achieve, that most planets that could host biological life don't develop it, that most species that do develop intelligence don't develop technology, that most species that do develop technology destroy themselves before developing the means to communicate across interstellar distances. The silence could mean civilizations are hidden, or the silence could mean civilizations simply don't exist in this galaxy. We can't tell the difference from the evidence we have. We're left with speculation and educated guesses and theories that are impossible to verify. What we do know with absolute certainty is that silence is a fact. The observable universe, all the light and radio waves we can detect, appears empty of obvious signals from technological civilizations. The sky is quiet, whether that silence is chosen or imposed, whether it's a conscious strategy or an accident of physics, whether it indicates a teeming galaxy full of hidden civilizations all observing radio silence or an empty galaxy with no civilizations at all, remains an open question that we cannot definitively answer with current observations. But silence is definitely a fact, absolute cosmic silence, and that fact has profound implications for humanity, because humanity is not currently silent. Humanity has not been hiding. Humanity has been broadcasting for more than a century. Humanity has been transmitting radio signals, television signals, radar signals into space, all unintentionally creating electromagnetic beacons that could be detected by any civilization that knows where to look and has sufficiently advanced technology. Beyond the unintentional broadcasts, humanity has also been intentionally broadcasting messages into space with the deliberate goal of reaching extraterrestrial civilizations. The Arecibo message sent toward a star cluster in 1974. Messages from various space agencies and private organizations, greetings from Earth, images of humanity, mathematical sequences, portraits of human leaders, sounds of human music, cultural artifacts, invitations to respond. Essentially, humanity has been shouting into the dark for decades with increasing volume, and if the dark forest hypothesis is correct, if silence is truly survival, if broadcasting is a death sentence, then humanity might be making a catastrophic mistake. Humanity might be painting a target on itself. Humanity might be announcing its location to civilizations that view younger species as threats or competitors or resources to be exploited. Humanity might be making itself known to entities that want to destroy it, or enslave it, or consume it, or simply eliminate it as a potential competitor before it becomes too powerful to stop them. This is where the dark forest hypothesis transforms from an abstract intellectual thought experiment into a practical question with immediate and real implications for human survival. Because if the dark forest hypothesis is true, If advanced civilizations across the galaxy are hiding because they've learned through hard experience that broadcasting is dangerous, if silence is the universal strategy enforced by the brutal logic of the universe, then humanity's current approach is not just mistaken, it's catastrophically wrong. Humanity is not just failing to hide. Humanity is actively advertising its presence. Humanity is turning on all the lights in a dark forest and shouting and calling out to anything that might be listening and might decide to respond. Humanity is doing exactly the thing that the dark forest hypothesis says will get you destroyed. Humanity is violating the first rule of survival that every advanced civilization has apparently learned, and humanity is doing this not out of malice or aggression or military strategy, but out of curiosity and hope and optimism. Humanity wants to believe that if we send a message, if we reach out, if we try to make contact, the response will be peaceful, that somewhere out there is a civilization of benevolent beings that want to communicate, that the universe is full of friends waiting to meet us, that the fundamental stance of intelligent species is to cooperate and help each other and coexist peacefully. But if the dark forest hypothesis is correct, if the universe really does work the way it predicts, then that optimism is not just naive or charming, it's dangerous. It's a fundamental misunderstanding of how reality works. It's a catastrophic failure to learn the hard lesson that advanced civilizations have apparently already learned through bitter experience, that being silent is survival, that broadcasting is suicide, that reaching out and making yourself known is the fastest way to invite destruction. The cosmic security dilemma emerges starkly from this realization. It's a genuine dilemma with no good options, only choices between different kinds of risk. Humanity faces a choice that might be the most important choice any species can make. Humanity could try to go silent now. Humanity could attempt to stop broadcasting immediately. Humanity could take down all the transmission stations. Humanity could try to become invisible to the cosmos and blend into the background radiation like every other star and planet. But doing this might mean sacrificing potential benefits of contact forever. Sacrificing the possibility of meeting allies who might help protect us, sacrificing the possibility of learning knowledge that might solve diseases and climate change and aging, sacrificing the possibility of acquiring technology that might help solve existential problems, or advance human civilization, sacrificing the possibility of becoming part of a greater community of civilizations, sharing resources and knowledge and culture. Going silent means accepting a future where humanity develops alone, isolated from all contact, dependent only on our own abilities to solve problems and survive. Or alternatively, humanity could continue broadcasting. Humanity could continue reaching out. Humanity could continue hoping for peaceful contact and beneficial relations. Humanity could continue sending messages and signals into space with the expectation that whoever finds them will respond with friendship rather than hostility. But doing this means accepting significant risks, real risks, accepting the possibility that humanity is already being monitored by some civilization that doesn't have peaceful intentions. Accepting the possibility that some advanced civilization is already listening and analyzing our signals and studying us. Accepting the possibility that humanity might be making itself a target for attack or conquest or resource extraction or extermination. Accepting the possibility that curiosity might come at a lethal cost. Accepting the possibility that reaching out could result in the destruction of human civilization. Accepting the possibility of discovering that the universe isn't a friendly place. And here's the tragic part of this dilemma. Humanity can't undo what's already been done. That's the crucial fact that makes this dilemma real. Humanity can't take back the signals already sent into space decades ago. Humanity can't reclaim the broadcasts already transmitted into the void. Humanity can't delete the messages that are now traveling outward at the speed of light, carrying information about Earth and humanity and our location in the galaxy. The Arecibo message from 1974 is still traveling outward toward Messier 13. Other signals have been broadcast since. The location of Earth is already out there somewhere in the cosmos, encoded in electromagnetic radiation, ready to be found by any civilization that searches carefully enough in the right frequency bands. The existence of humanity and the location of our world is already out there. We can't get that back. The signals are already gone. The information is already loose. The choice now is only about what humanity does going forward. The choice is binary and difficult. Keep broadcasting and hope for peaceful contact, or go silent and accept isolation, accept risk, or accept loneliness, accept the possibility of destruction, or accept the certainty of eternal isolation. Some argue that humanity should stop broadcasting immediately, that every additional signal increases the risk, that we should preserve what's left of our invisibility. Others argue that silence at this point is pointless because our presence is already known to any civilization that cares to look, so we might as well continue broadcasting and hope for contact with friendly civilizations. Some argue that the risk is negligible anyway because interstellar distances are so vast that no civilization could reach us in any reasonable time frame even if they wanted to destroy us. Others argue that we can't assume anything about travel times or capabilities or intentions, and we shouldn't assume we're safe. The cosmic security dilemma is that there is no safe choice. There is no choice that clearly minimizes risk for humanity. There is no option that doesn't come with real downsides and real consequences. Silence means isolation, broadcasting means risk, and both paths lead to uncertainty. Neither path guarantees safety, neither path guarantees progress. Both paths leave humanity vulnerable in different ways. Both paths require faith in assumptions we can't verify. Both paths require humanity to make a decision about the nature of the universe and the intentions of potential alien civilizations without having sufficient information to be confident in that decision. And that's the real terror of the dark forest hypothesis. Not that it's definitely true, not that we have evidence it's definitely how the universe works, but that it might be true. Not that we know the universe is hostile, but that we can't know for certain that it's not. Not that we have proof that civilizations destroy each other, but that the logic suggesting they might is compelling and hard to refute. The uncertainty is what makes it terrifying. The doubt is what makes it paralyzing. The possibility is what keeps us awake at night. Because if we knew for certain that the universe was safe, that all civilizations were peaceful, that broadcasting was harmless, then we would broadcast freely and reach out without fear. If we knew for certain that the universe was hostile, that civilizations destroyed each other on sight, that silence was mandatory, then we would go silent and prepare defenses and accept isolation. But we don't know. We're left in uncertainty. We're caught between two possibilities, and we can't determine which is true. And uncertainty about the potential destruction of your entire civilization is a heavy burden to bear. It's a weight that humanity will have to carry forward into the future, making decisions without certainty, taking risks without knowing the consequences, reaching out into the dark, hoping for a response that will be friendly rather than fatal.